Hello again. In the previous lesson, we finished exponential and logarithm applications. Now we're moving into trigonometry, and we will begin with angles and radians. So most students are familiar with degrees, but in higher mathematics, radians become extremely important. So let's begin with the quick rules. First of all, degree measure angles using 360 in one full rotation. Radians measure angles using arc lengths on a unit circle. Pi radians is equal to 180 degrees. And then when you're converting degrees to radians, you multiply by pi over 180. And then when you're converting radians to degrees, you multiply by 180 divided by pi. So the main idea is this: radians and degrees are two different ways to measure the same angle. That's the big idea. So let's begin first of all with example number one. Example number one, it says convert degrees to radians. So we have a set of degrees, and we're going to do just that. So to convert degrees to radians, we multiply by pi over 180. Okay, so when we're going from degree to radians, we're going to use pi over 180. Okay, so let's start with 30 degrees. 30 degrees multiplied by pi over 180, which equals 30 pi over 180. And then when you simplify that, 30 and 180 share a common denominator. So you can simplify them and you'll get pi over 6, right? Okay, so let's just say you divide by 6, that'll be 5. Divided by 6, that'll be 30. And then you can divide by 5 again. Okay, so um, so then that would simplify to 1, and then this would be simplified to 6. Okay, and that's just the speed round. Then you got, so we did 30 degrees. Now we're going to do 45 degrees. 45 degrees would be 45 pi over 180 equals 45 pi 180. This simplifies to pi over 4. Okay, so 45 degrees is equal to pi over 4. So notice we got pi over 6, pi over 4, and then let's do 60 degrees. Okay, 60 degrees multiplied by pi over 180. That's 60 pi over 180. Okay, which simplifies to pi over 3. Okay, and again, I'm just dividing by the common denominator, a common denominator. Then we have 90 degrees multiplied by pi over 180. That's 90 pi over 180, which simplifies to pi over 2. Okay, see the progression: 6, 4, 3, 2. And these things become more common if you haven't already memorized them. 60, 90, and then from there, we're going to do 180. So 180 multiplied, 180 degrees multiplied by pi over 180 is, that simplifies to, as a matter of fact, let me see, 180 pi over 180. It's going to simplify to simply pi. And then 270, or 270 degrees is pi over, or 270, excuse me, 270. As a matter of fact, tripping. That's 180. We'll get to that. Equals 270 pi over 180, which is equal to 3 pi over 2. Okay. All right. So just a summary, we have 6 pi, or pi over 6, pi over 4, pi over 3, pi over 2, pi, 3 pi over 2. So again, these are common angles. that we use very often. All right, example number 2. All right, convert each radian measure to degrees. So now we are dealing with the radians. These are called radians, like those were called degrees. And when we're converting radians, we use a different style. So we're going from radian to degree this time. And so in that case, we're going to use 180 degrees divided by pi. Okay. So radians to degrees, we do 180 divided by pi. That's very important. So we need to start with pi over 6 for this one, right? So pi over 6, right? And we're going to multiply that by 180 over pi, right? 180 over pi, the pi's cancel, right? Because you got 180 pi over 6 pi. The pi's cancel. So you have 6 over 180, or 180 over 6, which simplifies to 30, right? Or 30 degrees in this case. Okay. Then we have pi over 4. We're going to multiply that by 180 over pi, following the same sequence. 180 pi over 4 pi, or 180 over 4. 180 over 4 is 45 degrees. Okay. And then I'm going to shrink it. I'm going to omit this step and jump straight to this one so we can have room. So we did this one. So now we're going to do pi over 3. Multiply by 180 pi, which is going to simplify to 180 over 3. It's going to be 60 degrees. Then we have 2 pi over 3 multiplied by 180 over pi. So that's 2 times 180. 2 times 180 is going to give me 360. That's 18 times 18. That's 360 over 3, which is going to give me 120 degrees. Okay. And then we have 3 pi over 2. That's pi multiplied by 1 over pi. So again, the pi's simplify to 1. So we have 3 times 180. 18 times 3 is going to give me 500, or 18 times 3 is going to give me 54. So 540 divided by 2. 2 goes into 54 27 times. So that's 270 degrees. Okay. And then finally, we have negative pi over 2. So we treat it the same way, negative pi over 2 multiplied by 180 over pi. That's going to simplify to negative 180 divided by 2. Going to give me negative 90 degrees. Okay. So in summary, we're going to use this when we're going from radian to degree. You just use 180 divided by pi. And doing that, we multiply that by our current radian to get the degree. So 30 degrees, 45 degrees, 60 degrees, 120 degrees, 270 degrees, and then negative 90 degrees. Okay. All right, pause and try the problem at the bottom. All right, we're going to start with 225 degrees, and we're going to, since we're starting with degrees, we're going to radians, and then we're going to convert 5 pi over 6 radians to degrees. So we're doing two things in this problem. So let's begin with the first one. So we have 225 degrees, and we're going to radian. So in the same problem, since we're going from, since we're going from degree to radian, we're going to multiply by pi over 80. Pi over 180, not 80, 180. Okay. Multiplying by pi over 180, that gives us 225 pi over 180. Now, simplifying this fraction, we would end up with 5/4, right? Or 5 pi over 4. Okay. And since they both end in like in 5 and 0, you can essentially divide by 5 over and over and over again until you get to the desired result. So, but I just know this by heart. Okay. So 5 divided by 225, that'll reduce it. 5 divided by 180, that'll reduce it. And then you keep going until you get to the lowest possible value. Okay. Next, we need to convert, let's see, 5 pi over 6. So this time we're going from a radian to degree. And again, this was degree to radian. Now we're going from radian to degree. Okay. So 5 pi over 6. What we do with this one is we multiply it by 180 over pi. Okay. Multiplying it by 180 over pi. Now we have 5 times 180. 5 times 180 over 6. Okay. And again, um, I omitted the pi because they would automatically simplify to 1. Okay. So in doing that, 180 divided by 6 is, let's see, 150 degrees. Okay. You can easily do this. You can say, okay, well, six goes into 18 3 times, right? So that would be 30. 6 times 30 is 180, right? So then you do 30 times 5, which is 150 degrees. Okay, let's continue. Example number 3. Coterminal angles. Find one positive and one negative coterminal angle for 120 degrees and for 7 pi over 4. Okay. So coterminal angles share the same terminal side. For degrees, we add or subtract 360 degrees. And then for radians, we add or subtract 2 pi. So let's first of all start with 120 degrees, right? And we're going to add 360 degrees, and that's going to equal 480. Then we're going to do 120 degrees, and we're going to subtract 360. That's going to give us negative 240 degrees. Okay, so one positive coterminal angle is 480 degrees. One negative coterminal is negative 200. Okay, now we need to use 7 pi over 4, right? So to find coterminal angles in radians, we need to add or subtract 2 pi. Okay, so for this one, we're going to add and subtract 2 pi. Okay, I don't know if you can. So for this one, we're going to add and subtract 2 pi. For this one, and this is for for finding coterminals, we add and subtract 360 degrees. Okay, so when it says find one positive and one negative coterminal, just add 360 and subtract 360, and then that'll tell you what the value is for this one. And then for this, we need to add and subtract 2 pi. That's essentially what we're doing. Okay, so to find coterminal angles for radians, we need to add 2 pi, and 2 pi is essentially equal to 8 pi over 4. All right, so again, we're going to add and subtract 2 pi, and 2 pi is essentially 8 pi over 4. Okay, so we can rewrite 2 pi with a denominator of 4. And so that's just basically taking 2, multiplying it by 4 to get 8 pi, and then using the divider or the divisor of 4, because we're going to, as you can see, we're transitioning to a denominator of 4. So that's how we're going to play with this particular problem. That being said, we have 7 pi over 4 minus 8 pi over 4. And so notice we got common denominators, so that's how we're going to do that. Then we're going to set that equal to negative pi over 4. Okay. And then on the flip side, we'll take 7 pi over 4. We're going to add 8 pi over 4. Get 15 pi over 4. Okay, so we have our 2 positive and our negative. One positive coterminal angle would be this one. One negative coterminal angle will be this one. Okay, so the positive coterminal be 15 pi over 4. The negative coterminal is negative pi. And this is just one of the positive, and then one of the negative coterminals. Okay, so both 7 pi over 4 and negative pi over 4 excuse me, both 7 pi over 4 and negative pi over 4 point in the same direction. They just get there by rotating differently. Okay, now let's move on to example number 4. Okay, example number 4, we have S equals R degrees. So find the arc length when R is equal to 10 centimeters, and okay, and then this equals 3 pi over 5 radians. Then explain why that mean, excuse me, explain what that means in radian. Okay, so just to reiterate, use S equals R, and then this symbol is a Greek symbol known as theta. Find the arc length when R is equal to 10 centimeters and theta equals 3 pi over 5 radians. Then explain why theta must be in radians. Just to give you an idea, so radians, or excuse me, theta is essentially an arc. Okay, so this again is an arc length question. R is equal to 10, and theta equal to 3 pi over 5. And all we have to do is substitute. So we have S equals R times theta. So S equals R, which is 10, times theta, which is 3 pi over 5. Okay. 10 times 3 pi, so that'd be 30 pi over 5. which simplifies to 6 pi. Now, this is essentially saying the arc length is 6 pi centimeters. Now, we have to explain why theta must be in radians. Okay. The formula S equals R times theta is based on the definition of radian measurement. Okay. Radians directly compare arc length to the radius. Okay. So think about like you know, for example, if you were drawing a circle, right? Right. Just kind of do it like this right here, just to kind of show you like this is the arc, right? Okay. So degrees probably would have been better if I instead of using the right triangle. The degrees do not work directly in this formula unless we convert them to radians first. But the radians directly compare to the arc length to this radian right here. Okay, because remember you got to keep in mind that the radius is half the diameter of a circle. Okay, and the circle in question would be 360 degrees. Okay, so S equals R times theta must be in radians. All right. Common mistake. Here's the capstone. A student uses S equals radians times theta with theta equaling 60 without converting to radians. Correct the setup. So the mistake is using 60 as if it were radians. 60 is not radians. Okay. That's not radians. Okay. If the angle is 60 degrees, then we must convert. Okay. That is the key. We must convert it. So we have 60 degrees times pi over 180, right? And we'll get 60 pi over 180, right? And then that simplifies to pi over 3. So the correct setup is essentially S equals R times pi over 3, not S equals R times 60. Okay, just keep that in mind. All right, because again, this must be in radians, right? It must be in this format, right? Must be in this format, not this. Okay. All right, the final review. Quick rules for this lesson. You have um, degrees measure angles in 360 degrees in one full rotation. Radians measure the angles using arc length, right? The arc length in the unit circle. And radians or pi radians is equal to 180 degrees. And when we're converting degrees to radians or D to R, we need to use pi over 80. Then when converting R to D, we're going to use 180 over pi. All right. That concludes this lesson. Thank you for watching.